Well, hey guys, I just wanted to show you my parametric prop generator that I've spent quite a bit of time working on here over the last little while. This is in Autodesk Inventor Professional 2022. This is a program that I have created, not a program, but a file that allows you to use parametric creation to create a propeller using 5 blended NACA airfoils. Let me just show you the airfoils here. You can kind of see them inside the prop right there, and I'll show you how the parametric creation is created here in just a minute, but I'm going to zoom in and we'll show you how one of those is created. If we go into an airfoil, that one sucks. Let's try this one. Come on. There we go. Here is our airfoil, and if we look at this particular airfoil, you're going to see that it is created out of a variety of different equations. And these equations are quite in detail, and these come straight from the NACA 400 or 4000 series of airfoils. There's the entire file right across there. And these NACA 4-number airfoils were created back in the 1920s and 1930s, about 100 years ago. They mathematically define a propeller. And that's really all you need to know about them, other than they have a lot of different parameters to specify, and we'll look at those parameters here in just a second. I'm going to click Finish Up our sketch. It's going to, of course, recreate the sketch, which means my computer's busy working very hard, even though I am not right now. I did create a parametric menu, and we're going to go ahead and open up that parametric menu, and you can see where we can actually input the parameters and let the computer do all of the work here. First thing I probably should say, let me close that again, I want to bring up the sketches so we can watch that as we create everything. Let's make those visible for the moment. We'll zoom in a little bit on that prop blade so we can kind of see what's going on as we bring up this parametric menu. Now, on the parametric menu up near the upper left hand, you can see the NACA Airfoil Prop Generator by yours truly. Note, not for actual flight. Please use at your own risk, etc., etc., etc. You can see a graphic of a World War I style prop that I created using this exact same parametric model. And I'm going to show you the process of changing what is a 3-bladed RV6 type prop. I believe this is a 72-inch pitch with a 68-inch diameter. And we are going to create this monster of a World War II prop out of this prop, just to show you how all of this works and how we specify things. The first thing we have up across the top are the details of the hub right across here. And our hub is going to be similar, but we're going to make it a little thicker. It's going to go from 4.5 to 4.75 inches thickness. And you can see as you watch, the hub gets a little bit thicker down there. Now, my diameter on my World War I style prop is going to go to 9 inches in diameter, and so you should see again, it changes. I'm going to put a 3-inch counterbore on it, and so the counterbore changes, and we're only going to have a 2-bladed prop. So there you are. Now, this is also going to be a little simpler for the computer to calculate. In reality, I should probably switch this to a 1-bladed prop while we tweak it. And then, yeah, 1-bladed props don't spin very good. But we'll make it into a 1-bladed prop, and then we'll come back and add our different numbers of blades as we play with this. So I am going to put 8 bolt holes on my prop. Oh, what the heck? Why not put 9 of them just because we're creating our own prop hub? Nope, I like 8. Back to 8. And our bolt hole diameter, let's go with 0.625, a 5/8. That's a monster bolt on this prop. Our bolt hole circle probably needs to be a little bit bigger. How about we go with like 5.5 inches? And now, here comes our mathematical base pitch. And what you need to know about this base pitch is it calculates the angles of all of the airfoils based on the pitch that we specify. So that 72-inch pitch for the RV6 prop is going to become, let's go with a 32-inch pitch for our World War 1 style prop. And so you can see that that blade is much, much flatter now than it was. And we're going to tweak that base pitch in just a little bit. By the way, I can specify a right-hand rotation or a left-hand rotation by changing this number. And you can see that it goes ahead and pops, literally just makes the opposite blade to begin with if we put the opposite blade parameter in there. But I'm fine with that. I want to keep this as a nice proper prop. And here we go. Now the next thing I'm going to specify down here is the airfoil locations. And these are specified in distance from the center of the hub. And by changing these airfoil locations, I'm allowed to find out or change the diameter of the hub and also how these things are blended together. I'm going to leave that first one at 1.5 inches. And since I have a 9-inch hub, that's buried deep inside the hub. You can just barely see this little fella down here inside the hub where this airfoil is being generated. But I want that because I want it to blend nicely into everything. So I'm starting down at about 1.5. And on my bigger prop, I'm going to go with a 6-inch for my next station, and you should see it pop outward as soon as I do that. Of course, it has to recalculate everything. Then we're going to go to a 16-inch on our third station. Our fourth station, we're going to specify at 34.5. And I'm guessing we're going to have an error here as we try and do it because I no longer, well, it's an error all right, but not the kind I thought we'd get. We're going to bring that last one out to 42. And that's going to give us our bigger prop. Now this thing is going to be an 84-inch in diameter prop because that far out blade is, that far out airfoil is 42 inches from the center. The next thing we're going to do is we're going to specify our chords for each of these individual prop hub areas. And I'm going to start with a nice fat 8-inch chord line, and you can see the inside, you'll just barely see any changes as that inside chord goes ahead and increases. Then we're going to go to a 6-inch, nice little tight-waisted next airfoil, and then I'm going to go 9, 8, and 3.5 on the remaining airfoils. Gotta wait for the computer to do its thing. 8, and there's our 3.5. So this gives me the individual places. Now the next menu I need to show you is the individual tweaks, and if I just leave these as all zeros, it gives me a straight mathematical twist on the blade. And back in the day when I used to teach propellers, I used to teach that this is how a propeller is taken care of and how this is how a propeller works. And let's go ahead and pop that up along the side so you can see that mathematical twist happening. Nice mathematical twist, but in real life we don't actually necessarily follow those exact parameters, and we're going to tweak these out to a little bit different than that. In fact, I'm going to go with a -3 on the center, and that means it's going to be, the very center is 3 inches less pitch than the rest of the prop is. And then I'm going to go with 2 inches of less pitch than the prop is. And then I'm going to go with 1 inch as we go to these various airfoils. These changes are small enough you're hardly going to see anything happening when I make them. And now I'm going to go to a 2-inch more pitch on the very tip. And what that's going to do, hopefully you can see just a little change. I really didn't even see any change. It just slightly tweaked that airfoil into a little bit more of an angle to bite just a little more air around the outside edge. And if you want to see more about that, look at Alvin Schubert's How I Carve Propellers. He has a really wonderful description of why that would be done. Now, the next thing I'm going to come along to, as I'm moving my way through everything, is I am going to look at the fine position tweaks. These fine position tweaks let me move an airfoil from place to place. So for example, if I look at that very last, it looks like I mislabeled it as airfoil 4, but if I look at that very last one and I move it horizontally 3 inches forward, you should see quite a change on my propeller as that thing moves forward 3 inches. Let's go ahead and put it back at its standard location. And maybe I would move it forward 3 inches in the vertical direction. And you can see that it's now swept that propeller into a nice upswept tip. And with these, I can actually control the basic blade parameters or geometry of the blade. And so we're going to do our fine position tweaks. And I am going to go with 1.5 on my vertical, and takes it a moment, negative 0.5 on my, the 1.5 was on the horizontal, the negative 0.5 on the vertical. I'm going to go with 1 and negative 0.25. And then we're going to go with 0.3125. Oops, I wrote 0.41. How about we go with 0.31 as advertised? And we're homing in on our positions here. Negative 0.1875, 3/16 in the negative direction on this one. This brings us to 0.25, and I'm going to go ahead and zero this one out on the vertical. And then my last one is going to be 1 inch, and we are going to zero this thing out as well on the vertical. And this is going to specify the basic hub that I'm looking for. Okay, the basic propeller that I'm looking for as I move my way across here. And really the only thing I don't like about that is I don't like this vertical on that last propeller blade. So let's go with negative 0.5. I'm going to try and home that thing in until it looks, that looks significantly better, but I think maybe 0.75. We'll just tweak that until I'm happy with it. I have to actually exit the parameter. That doesn't look too bad to me. All right, I'm starting to see a nice twist on that blade. Now, not really sure. I think I want that to go a little farther forward. How about 1.5? Yeah, that's a little more like what I'm looking for. I could maybe move airfoil 3 backward just a little bit. Let's go with 0.25. Just a 1/16 of an inch. You'll hardly be able to see anything, but we're talking fine tweaks here to try and make this thing into what it is that we want. All right, that gives me my basic blade shape, so I'm going to go ahead and move to my very last section, and that is my NACA numbers. And to really see what these NACA numbers are, I really recommend you go to Wikipedia and look at their cambered 4-digit NACA airfoil section, and it has a really good explanation of what these are. But you can enter the specific airfoil for anything you want it to be. And so I'm going to start my root as a 6000 series with its fattest point 30% back, and it is going to be 90% thick. In other words, it's almost a circle. And so there we've gone ahead and created it back there. And then we're going to move into our airfoil number 2, which is not possible with the NACA schema, but there isn't any reason why I can't go ahead and go with halves on my mathematical calculation. So we're going to go with a 4.5, 3, and 50%. Of course, on a real prop, we are going to definitely want to have thick airfoil sections in the center, and as we move outward, we're going to want to have thinner airfoil sections so that they cut through the air nicer. Let's move into, how about a 3,300, come on, and 28% on our next one. And now, by the time we get out here, we're swinging pretty fast, so I'm going to give that a 2, 3, and we'll go with a 16. A wood prop's probably going to be a little thicker than a aluminum prop, so we got a 2, 3, 16. And then we're going to go with a 2, 4, 10. We'll keep that same one. And now you can start to see this prop is definitely taking shape. And some of these tweaks have kind of affected how other things look. And because they've affected how other things look, I'm going to want to tweak it a little bit again. And I'm looking at that and I'm going, you know, it moves a little too far forward over here. So let's try and move it back a little bit on that tip. In fact, looks like about 1 is where I want it to be. And yeah, let's try 7/8. 0.875. Let's see how that looks. And the whole thing here is we're just playing with this. We're making it so that we like what it looks like. Maybe I could go to that third airfoil and I could go, you're really getting pretty fat at that third airfoil. You can kind of see where that third one is. Here's the first one, the second one, and the third one. If you're too fat at that airfoil, we don't need 28. Let's go with 23 instead. And I'm just kind of guessing here. And you can see how that thins that airfoil up and lets us play with it a little bit more. Also, I think I want to go to a let's go to a no, I'm happy with that. I'm good with that. We're good. Okay, I've got my blade. I'm pretty happy with what my blade looks like. And the only thing I'm really not sure about is that base tweak section. But I guess that's where it is. That's what it's going to be doing. So we are going to then go ahead and say, yep, we're done with that basic section across there. There is our single blade. Oh, we forgot one important thing. We want to go back in and we want to specify that this is a 2-bladed prop. Okay, so pow, there is our matching blade across the other side, and you can kind of see where everything is. And of course we could spend a lot more time tweaking everything up, and if I were going to actually try and carve a blade, I would probably spend a lot more time doing this, but this is going to be good enough for what we need to do. Now at this point we can start playing with this blade in using regular modeling skills, and we can do all kinds of different things to it, but that's kind of up to what we want to do. I'm going to disappear our sketches so they're not distracting anymore. They're not visible anymore. I am going to probably clip a little section of this, of the front of this, where it juts out past my hub. So there we have that, and that's gonna trim forward. And so let's see what we got here. Nope, I want it to trim that direction. And there we are. And we probably need to do the same thing on the back side of the blade, although there's just not much to trim on the back side of this blade. I do think we want to do it though, so let's go ahead, and this is going to bring us out to maybe about there. And you can tell this is very scientific design at this point. And we want to cut this sucker away. Once again, I'm moving the wrong direction. How about that? That looks like what I want. And now I should have my basic prop done. Of course, I could move in and I could put various different fillets onto it to make everything look good. Let's try a maybe an inch wide fillet across here, and maybe another one right there. And hopefully it'll let us do that. It has a mind of its own when it comes to what it will fillet and what it won't. Okay, it didn't like that. Let's try again. 0.5 and 0.5. Yeah, it could handle 0.5. Let's try 3/4 and see if it'll take that. Starts to have internal, nope. 5/8. There we go. Starts to have little internal errors as it tries to calculate everything out. And so we could spend a lot of time trying to clean things up, but I'm just not going to worry about it that much, because the whole goal of this was to just show you what you could do with this. Of course, back in World War I, they made them out of walnut, so we'll make our nice walnut prop. And you can see we're definitely starting to look like that one that you just saw. There's our nice little prop. And there's one more thing we did do on it, I believe. If you were to take a look at it, we could trim the blade a little bit. So we could start a sketch and maybe make a sketch right across here. And yeah, that's what we want. And we're going to need to kind of trim a blade, so let's project the end of the blade and maybe the leading edge of the leading edge across there. And we could probably put a 1-inch spot across there, and I'm sure we could come out and put a nice little rear curve onto everything. Let's see what we got here. How about we bring that to about there? And yeah, I'm not doing it very sophisticated, but you know, I don't need to be sophisticated right now. I'm okay with that. There's my basic trim across there. And all right, so we're going to do that through everything. Both ways. All right, there we go. Yeah, why not? While we're playing here, I mean, what's a few more seconds? Let's go ahead and bring that out to a 2-inch radius. And I think I've had enough. I think I've done enough here, so we'll wrap this thing up by sending this extrusion. I want to say that was around our y-axis. There we go. We got 2 of those, and we can put those on both sides. And the last thing we're going to do is just to show how pretty our prop is. We are going to view it in realistic, and we're going to ray trace it. And there she is. Now, of course, you look at all kinds of videos on Autodesk Inventor and talk about look at how you could stress analyze this. Hint: Autodesk Inventor doesn't do a very good job of stress analyzing because it doesn't have appropriate materials for actual wood analysis. It analyzed an aluminum one really nicely, which I guess we could have if you wanted it, you know, just for the fun of it. If we made this out of walnut, this is a monster of a propeller. It is going to take it a minute to calculate all that because it's a pretty complicated geometry, but it'd come in at 20 pounds of walnut. Now, we wouldn't actually make it out of aluminum in this same thing, but let's just go ahead and select 6061 and see what that would do to us. And we're at almost 100 pounds of aluminum if we were to have it. So, yeah, that was definitely an advantage of walnut. But we can put her back to walnut. Or, maybe we could live really dangerously and go to oak. All right. Ash would make a nice prop, but I don't believe we've got any ash. There are ways, of course, to redefine things, but I've said as much as I need to say in this, so the only thing I'm going to wrap up with is this is a program that I am going to be providing on Grabcad, so you can download it from Grabcad. It only works on Autodesk Inventor, at least version professional, at least version 2022. And this is free for educational use, etc., etc., etc. Please don't actually fly behind this. If you do any derivative works, I do appreciate being cited. And watch for more details on the Grabcad model. And with that, I'll say thanks for watching. If you're still with me, you had a lot of interest in this subject.